Today, I'll be sharing my reflection on the video from sand to silicon, which is a chip manufacturing, or which explain how microchip, the brains behind our modern technology, are made. So before watching the video, I honestly didn't realize how something as simple as sand could be turned into the most advanced inventions of all time. It amazed me to learn that silicon, which comes from sand, is the foundation that every chip of the powers our phones, laptops, cars, or even renewable system. So the process is start with the sand that contains a silicon dioxide. This material is purified and also transformed into silicon crystals called ingots or pots. These are then slide into thin wafers, which become most base of our building microchips. At first, I thought it was already the final product, but I learned that it's only the way of the beginning. The real magic becomes happen through the following stages, including the oxidation, doping, photolithography, and etching, which all of require extreme precision and cleanliness. So, one thing that really stood out to me was how clean rooms are maintained. The idea that only one dust particle is allowed in 10 liters of air shows that how sensitive and delicate chip manufacturing is. So I imagine how difficult it is must be hard for engineers and technicians to work in a such controlled environment, wearing their full body suits, avoiding the perfumes or makeup, and going through airlocks just to enter the laboratories. So it made me appreciate the discipline and dedication behind the technology that we often take for granted. So another part of fascinating for me was the concept of topping. I've learned that by adding tiny amounts of other elements such as a phosphorus or boron, silicon can become either conductive or non-conductive. The small change allows the creation of transistors, which act as the basic blocks of every microchip. Even though the transistors is a microscopic, billions of them are connected to form circuits that performs complex operations in our devices. So while watching the video, I realized how the processes in a mirrors real life. Each step from refining the raw material to testing the final chip, it takes time, patience, and attentions to all the details. Just like in life, we started as a raw materials too, full of potential. Through challenges, learning, and refinement, we eventually become capable of doing great things. The video also made me appreciate the people behind this innovation, scientists, engineers, and workers who dedicated their skills to pursuing technology forward. Their work doesn't just make gadgets for faster or smaller, it also helped society. For example, was the power semiconductors are now used in the renewable energy makes the system like solar panels, electric cars, contributing to a more sustainable future. As a computer engineering student, this video inspired me to think deeper about the technologies I've been used every day. So it reminded me that everything in tech, whether hardware, software, or networking, starts with the basics electronics. It made me more excited to continue learning about the circuits, semiconductors, and even the computer system, knowing that these lessons are the part of something much bigger. So in the end of this reflection part, it taught me technology is not just about the machines, it's about the human's creativity, patience, and precisions. The transformation from simple sand to powerful microchips is a proof that even the smallest materials can hold emerge potentials just like us. With enough dedication and curiosity, we can also create special something impactful no matter how small we start. For the second one is we have the why chip making is so hard. So before watching the video, I honestly thought Making computer chips was just about the programming or assembling in a small parts. But I learned that the chip making is one of the most complex and delicate manufacturing process in the world. So every modern chip contains a billions of transistors that are similar than a single strand of a hair, which and creating something that tiny requires incredible precision. So one thing that amazed me is how expensive and specialized the process is. Building a semiconductor factory that can cost tens of billions of dollars, and even a tiny mistakes like a speck of dust, it can ruin a whole batch. That's why these chips are made in clean rooms with advanced machines that work in a microscopic levels. I also realize that no single country or company can do it alone. The semiconductor industry depends on a global corporation. Some companies designs the chip, other manufacturing them, and others create the tools and materials needed for production. For example, is there only one company in the world, ASML from the Netherlands, that produces the machines for extreme ultraviolet lithography, the technology that makes advanced chip possible. What struck me most is how fragile and interconnected this system is. A disruption in one part of the world, like a political conflict or shortage materials, can affect chip supply everywhere. So it made me realize like how dependent our everyday lives are on these tiny chips that power on our phones, laptops, and even cars. So let's proceed on a reflection of photolithography. So this will be a think about the gadgets we use every day. Our cell phones, computers, or even televisions is often to forget that they all rely on something extremely small yet powerful. It is called the microchips. And every behind chips there is a called photolithography, which allows engineers to print microscopic circuits on silicon wafers using light. So the word photolithography is actually comes from the Greek "photo" means light and litho means stone and graphein means writing, so together it means writing with the light. It was named perfectly describes that happens during the process. Patterns are even transferred onto silicon water, wafer using light, just like how we print images, but on a credible tiny scale. So I learned that the photolithography was invented back in 1855 by Alphonse Poitevin, long before modern technologies are even existed. He discovered how light and chemicals could be used together to create patterns, a discovery that became the foundation of a chip, today's microchip manufacturing. So in a modern times, the process is much more advanced. It starts with a silicon wafer that is cleaned carefully to remove any impurities. Then the wafer is coated with a light sensitive cold chemical photoresist through a method known as spinning coating, which spreads the liquid evenly across the surface. So after that, a mask, which contains a chip patterns, is placed above the wafer. When the ultraviolet light passes through the mask, it changes the photoresist in a certain areas. Then the developer washes away parts the photoresist, and the remaining areas protect the silicon beneath it. This process is repeated many times, creating layers upon layers until the full circuit design is complete. So it is an incredible, precise, and delicate process because these patterns are smaller than what the human eye can see. So the technology has also improved over time, from using mercury lamps with the long wavelengths to laser system that use much shorter wavelengths, allowing them to finer details. What really amazed me is how photolithography combines with the physics, chemistry, engineering at all once. It shows how science can be used creatively to build things that power in our digital world. So, through this lesson, I realized how much effort, innovation, and precisions are needed to create even the tiniest chip. It's not about something we often to think about, but without the photolithography, there would be no smartphones, computers, or even a modern technologies. So this topic made me really appreciate the technology are more deeply and remind me how much human curiosity and creativity have shaped the world we live in today. Let's proceed to how CPU is made. So in this reflection video, before watching this, I honestly realized how complicated and precise the process of behind the chip could be. We use computers and phones every day, but seeing these tiny devices are built made me appreciate the science and technology behind them even more. So it starts in a very simple, which is the sand. From quartz sands, engineers extract and purify silicon, which is melted and shaped into large, perfect silicon crystals. So from these crystals, thin waters are sliced, and these wafers become the foundation of every microchip. Once inside the clean room, the wafers go through the hundreds of steps. The environment is kept so clean that is over 100 times cleaner than the operating room. So this is to make sure not even single dust particle interferes the chip's microscopic structures. Then comes to the photolithography, where the wafer is coated with the light sensitive, it is a chemical and exposed to the UV light through the mask. These transfer the secret pattern like printing billions of tiny transistors using the light. So afterward, etching removes unwanted areas, forming the structures of the transistors that will make up the CPU. So for the next process is the ion implantation begins. This is where the electrical properties of silicon are modified by adding the atoms that make it either conduct or resist electricity. This step is essential for creating the logic, memory functions inside the CPU. Later, cupping wire connects the billions of transistors together to form a complete integrated circuit. And finally, after months of testing, inspection, and grinding, the chips are out. It was packaged and sealed, ready to become the brains of the computers and other the smart devices. What amazed me the most is something as small as a fingernail can hold a billions of transistors, which working together in a perfect harmony. It made me realize that behind every fast, efficient, and powerful computer, there are countless engineers, scientists, and machines working with a nanometer precisions. This reflection remind me how human creativity, innovation can turn into ordinary sand into something that powers our entire digital world. It's truly fascinating how far technology has become and how much effort goes into every chip that makes our modern lives possible. Thank you for watching this reflection.